Okay, in this video we're going to find the domain and range of a function given the graph of the function. Okay, so the key thing to remember here is that the domain of a function is the input values of the function, commonly referred to as the x values. The x values. Okay, and specifically when we're talking about the domain, we're talking about what x values are used by the function. So let's look at this graph. And the x values are listed along the x-axis here, and we have an x value of 1, which we can see is not on our graph, and an x value of 2, which is not on our graph. In fact, none of the x values to the left of 3 are used in our graph. Our graph doesn't start using x values until it gets to the 3. And then an input of 3 yields an output of 2, and an input of 3.5 yields an output that looks to be about 2.7. Input of 4 outputs a value of 3, and so we can see here that the domain goes from 3 all the way over to the right. So there's a couple ways we can write this. We can write that x is greater than or equal to 3, because 3 is actually an input value. We could write that x is between 3 and infinity. Or we could write that 3 is less than or equal to x. All of these ways are fine ways to express the domain of this function. So let's look at the range. Now, the domain are the input values, the range is the output values, um, commonly referred to as the y values of the function. So, the y values. And looking at this function, we can see that it doesn't use a y value of 1. This y value is not in the function, nor is a y value of 0 or -1. The graph doesn't start using y values until it gets to 2. That's the first y value that appears in this function, and then 3 is in this function, 2.5, 3.5, and since the graph keeps going forever in this direction, the range starts at 2 and goes up forever. So the range is y is greater than or equal to 2. Or you could say 2 is less than or equal to y, which is less than infinity. Or you might word this as 2 is less than or equal to y. Okay, that's the domain and range of this particular function. Let's go look at another more interesting function. So in this function, you'll notice that there's a disconnect here. The function goes till it gets to 2, and then it picks up back again at 3 with nothing going on in between. So let's look at the domain and range of this function. We'll start from the left. It doesn't use -4 in the domain. The domain doesn't pick up until it gets to -3. That's the furthest value to the left for the x values. So I know that -3 is in my domain, and all the values between -3, so -3, -2, -1, 0, 1, all the way up to 2, but not including 2 because of this open circle. So I know that -3 is less than or equal to x, which is less than 2. Is part of my domain. That's the domain of this part of the graph. Now, 2.5 is not in the domain of my graph. That's why I had to stop this statement. 2.5 is not in the domain of my graph, but 3 is. So the graph picks back up at 3. So 3 is less than or equal to x. And the graph keeps going to the right forever. So circling my domain values here on the x-axis, and then it goes from here all the way to forever. As you can see, the graph keeps going. So it is less than infinity. And that completely describes the input values of this function. Let's look at the output values, the range. All right, so again, we're looking at the y values. Starting down here, looking at -1, the graph will touch at -1 all the way over here on the right. In fact, it'll keep going forever, hitting all the negative y values. At 5, it touches over here. So it looks like from -infinity up until +9. This is the highest y value that it'll touch. So the easiest way to write the range is that y is less than or equal to 9. You could also write this as -infinity is less than y is less than or equal to 9.